Michael Daly
Michael
and
and
Bart.
Mike Bart. So they're going to talk about engineering through the eyes of Henry Royce.
We're going to talk about cars and BGP monitoring.
Well, yes, I was going to get to
Oh,
Henry
sorry.
Ford and Henry Royce.
Sorry.
So, I do remember some of the notes.
Yes.
Anyway, perspective of BGP engineering from a car manufacturer.
Yes.
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 Enjoy.
Thank you.
You have half an hour.
We do. Great.
Actually, you've got 35 minutes probably if you were
Well,
to run over.
I could talk all afternoon about this if you like.
As I was saying, you've got 5 minutes.
Okay. Thank you very much. Good afternoon. Thank you for having us. So I'm Michael Daly. I'm Senior Director of Engineering at Imperva. Imperva do Cloud WAF, various other bits and pieces like that. And essentially I look after network engineering, or some of network engineering, SRE, infra-eng, and network automation, which is where Bart comes in, who's now running away from me.
Yep, I was. Sorry. You go ahead. You go
Cool.
first.
So I've been in this industry for 30-something years now, starting off doing help desk stuff, building networks for Mercedes-Benz, then into network engineering, and then later into management.
Yeah, I'm Bart. I've been there a little bit less long, right? You can see that from the hairline, I guess. So that's
Why do I put up with you?
so about 20 years. Originally from networking, and then I realized like there must be a better way than using Notepad all day doing VLANs. And I'm not referring to Notepad++ by that, right? But so went into automation, scripting, development, and here we are.
The mandatory corporate slide. Imperva do all kinds of interesting things, CWAF, DDoS, and security tools. We have 65 now POPs around the world in various locations. We're managing over 1,000 network devices. We're managing over 4,000 servers. We were purchased by Thales back at the end of 2023. So we're now part of that whole big 80,000 person company as opposed to the small 1,400 startup-ish like company that we were before. So Imperva has a bunch of issues that we're trying to solve at the minute around the automation and the network stuff. Many systems that make changes at the edge and they don't talk to each other well. There's lots of old code because it's all grown organically over a long period of time. There's no real modern libraries and there's very little documentation. Stop me if you've heard that one before. So what we have is we have a rocket ship. We have this great piece of infrastructure that does this great stuff. It must be particularly good. Somebody's paid $3.7 billion to buy us. So we're doing all right. But it's very old. It's antiquated. It's out of date. It needs some revision. So 1863 was a great year for cars. This gentleman, Henry Royce, was born. Now, Henry was obsessed from a very early age with engineering. He built lots of things really, really well. And then with a bit of a loan from a friend and some investment from his family, he started a business making, anybody? Cranes. So Royce cranes were the best. They were well engineered, they were well thought of, and he was obsessed with making them right. Around the turn of the century, there was lots and lots of imports from America, from the Italians, from the French, but they weren't quite as good as the Royce crane, so he kept going and kept going. So Henry was obsessed with precision, or he was obsessed with accuracy, because the two things are kind of the same, they're kind of interchanged. So let's just talk about that very quickly. My very first job was with Mercedes-Benz. Now, when you joined the board of Mercedes-Benz, the managing director gave you a watch. This was his watch. Now, this watch was synchronized with rugby in the UK, and it meant that you could never be late for a meeting because your watch said the same time as his watch all the time. This was very precise. This is my watch. See, I'm wearing it now. And it's been around. I've had this watch for 20-something years. My wife bought this for me, and I adore this watch. And I spent the price of 2 Apple Watches having it refurbished last year. That's how much I love this watch. I'm not going to change it for anything. But when I got off the plane in Copenhagen yesterday, I had to adjust it. Every so often it runs a little bit slow, so I have to change the time. So it kind of has to be adjusted manually from time to time. Now, I've never missed a train or a plane because of this watch at all. So here is the difference. Alexander von Weissleder's watch cost $1,000 and it was precise. My watch cost $1,000, but it's merely accurate. And that's the difference. So 1863 was a great year for cars because this gentleman was also born, Henry Ford. Around the same time, maybe a few months different. Now, he learnt his engineering from threshing machines and tractors and other things on the farms he was working on. But again, obsessed with engineering, obsessed with making things really well, kind of kept moving on. Around the turn of the century, so we're talking about 1900, both of these men were quite wealthy industrialists, and they both decided they really wanted to get into cars. Thankfully for us. Well, for those of us that like cars anyway. This is the first car that Henry Royce bought. It's a Dion Boutron French-made quadricycle, they called it. Essentially, it's two bikes with an ICE engine in it, internal combustion engine in the middle. He thought it was very well made. He thought it ran nicely. It was okay, much better than the American imports of the time. From that, he then went and bought this. This was his first proper car. Now, he loved this car, but it was a bit slow and it overheated and the brakes were a bit shabby. So he spent lots and lots of time working on it, making it better. Nothing was too trivial to get his attention and to be taken apart in his workshop. That then led to this. This was the first sort of Royce car. 10 horsepower. Now, he literally was, this was a work of love. I mean, he put more time and energy into this than he did in his children, I think. He would improve the brakes. He changed from chains to drive shafts. He did a lot of engineering on this to make sure it was absolutely perfect. And it was, and it ran really, really well. People loved it. From this, one of his engineers once said, there was nothing he wouldn't change on this car. There was nothing he wouldn't file. There was nothing he wouldn't fettle. There's nothing he wouldn't balance, just a little bit better to make it more and more precise. Following from that car, he met this gentleman, and history was made. We now have Rolls-Royce. This is the first car that Rolls-Royce made together. This was nicknamed the 2040, but it was painted silver and it was called the Silver Ghost. Everybody's heard of a Silver Ghost. This car ran up and down the country, from London to Scotland, from London to Scotland, backwards and forwards, and it never once broke. That was unusual for the time because cars broke down all the time, right? They were unreliable, they weren't well made, they were kind of thrown together, but this thing ran and ran and ran and ran and ran. This is the same car 100 years later. The rubber's been changed on the wheels because rubber decays. The leather's been changed on the seats because leather decays. The engine, the chassis, the rolling gear, the gearbox, it's all the same car. That's how well this thing was made. So, rather than going out and buying a quadricycle, Ford decided he would just make his own. Built it in a workshop, ran perfectly well, it did okay. This was then the first car he made under his own name properly. And again, it was made of good materials, wasn't overly expensive, wasn't particularly fancy, but it did the job it was supposed to do. It was an affordable car for many people to own. That was what Ford's goal was. Now, this is the Model T. Everybody knows about the Model T. This is the car that changed the world of manufacturing, changed how things work. In a Rolls-Royce factory, when they make the car, they make bits all over the place, then they pick them all up, and they wheel them into another room, and they try and put them together. And most of the time, they don't actually fit very well. So they have to bend them and fettle them and polish them and shape them and do some other bits and pieces. And all of a sudden, you have this car together and it drives out the factory. And it's a Rolls-Royce. It drives out the factory. It's great. It's a Rolls-Royce. But still, they've had to take something and change it to make it work. With the Model T and with Ford since, they roll down a production line. Somebody walks in, takes a part out of a bin, plugs it in, and it goes down the line. Everything is made to fit as it comes onto the production line. They don't have to make any changes to it as it goes. So here's the difference. Fords are precise, Rolls's are merely accurate. So, how does this affect the work we're doing at Imperva and how I've worked in other companies? Most companies make their software like we make Rolls-Royces. You take talented software designers, you take talented engineers, and they sit in separate rooms and they write code. And this code is fantastic. I mean, it's great code, but all of a sudden you've got to deploy it, you've got to monitor it, you've got to run it, you've got to look after it. And so you hand it down the hall to an SRE who goes, well, that doesn't fit. Put this in and plug that in and do this other thing. And they mean, all of a sudden, you've got a piece of software that goes out to the world and does excellent things. But it was accurate and you had to make it precise. For anybody that's interested, the tea here is excellent. So it's a Rolls-Royce. We make Rolls-Royces and we do it really, really well. But we should be making Mustangs. As a developer writes a piece of software, he'd reach into a parts bin, pull out the observability piece, pull out the monitoring piece, already done monitoring, pull out the observability piece, plug in the deployment piece, plug in whatever else it needs to be done, and this thing should just roll on the production line, roll it in production, and be perfectly happy as it goes. So, how do we do this? So Bart's going to talk about that in a moment, but essentially, we run to rigorous standards on everything we're doing at the moment. No backdoors to everything, to anything. APIs are the way to go. There's no tricky little database connections at the front. If you need data from something, you have to go through an API. Everything is done to rigorous standards. Everything is done to the same code. We rigorously review everything that goes out into production from this automation team, and we make it work. So, Bart, your turn.
Thank you. So I'm going to take you to one of the projects because we got limited time, so we need focus, right? So the BMP journey, the BGP Monitoring Protocol, is where it all starts. And let's start with the use case. What was desired? What was desired was to be able to present to our customers, our DDoS or anti-DDoS customers, to present the data to them, essentially giving back the prefixes, the things that whatever they configured in our system, which gets configured automatically, all that stuff is beautifully happening, and that was there already. But being able to present that back to them and saying, okay, well, hey, you've configured this, right? You advertise that certain prefix or a bunch of prefixes. We are actually learning that, and all is green, all is good, right? So that was the intention. But that's not where we were, right? Where we were was we had people with access to the CLI because we're network engineers, we love our CLI. And those we were able to get certain data from the boxes, right? But not everybody should have access to the box, but they do need access to the data, right? So we have there this looking glass, and they are able to do their clickety-click in the GUI and get the information from that. And that works for them, right? They can get access to the data. They can get the BGP summary, they get the advertised prefixes, they get the received ones, the pre and post policy data. They can get the commands in there and get the information out, and it gets presented in the GUI, and all is good, right? NOC can access it, the network operations can access it, everybody can access that. All good. But having access or needing to go to a device and get the pre and post policy data for a box, there's not I don't know of a vendor that you can just say, okay, give me all of that for every prefix, every peer that there is on the box, and just give me that in a standardized format back, right? So what usually you need to do is, and this looking glass does that in the background, right? It translates the input and get a nice show command, and it will get that data. But you need to do that per peer, right? To get pre-policy data, you need to do it again. To get post-policy data, you want to look at the routing table, you have to do another command, right? So you'll end up in different commands, and if you would do that continuously on the box, you get an overloaded box, which is already doing a bunch of stuff on the network, right? So what if we can offload the desired data, right? Not having to go to the box, the online box, but actually have that offline in a database, both the pre and post policy data, preferably without a real burden to the device, right? Easily accessible by the different teams, and as a bonus, perhaps an historical view of what has happened throughout time. So we used to talk about building blocks, and everybody does that, right, in their architecture design and their software, and Michael mentioned it, putting all the things together. But on top of that, I'd like to call them focus blocks, right? Especially since we started on this just journey with Michael on how we build the software, how we build the things, and having them really focused on it should do one thing, and it should do one thing really good. So if we're going to have a look at the architecture, right? We got the routers, and on the routers, we're going to configure BMP. For those who are not familiar with it, it's like a route reflector, but then from the BGP protocol into a BMP protocol, and which would go to a collector, right? The collectors in our case are containerized, and they run on a server. It's written in Go. Credits go to Cloudflare for having a BBMP to Kafka repo for building that piece of software, and that's what we reused in this case. Once it gets to the collector, right, it gets put into a protobuf. Some stuff happens on that service. and we dump it into Kafka, right? Since we got a whole bunch of POPs, 60 plus, we want to dump that in Kafka, so get that offloaded, get that out of the way, and then we can have a centralized consumer where all of the data is taken from Kafka and then thrown into the database. As Michael mentioned, we don't want people directly communicating to the database. They shouldn't have access to that. The least amount of people should have access, and we just want an API, right? You need certain data, you need it in a certain format. Sure, you get an API endpoint for that. But preferably make it easy, right? Get all the data in a single query, and you're good to go. There might be some filters on there, but the data is what they need to access. So, taking you again on the journey, right? I start happily coding and doing the thing that I love. We get a piece of open source software, and we're going to look at it. Yeah, it looks great. We're going to push it onto Kafka. We get all the bits and pieces. We work together with the engineering team, and there's going to be deployment in Kafka. We need a topic, and we need the bits and pieces in Kubernetes, and we get an API. We need a Lambda somewhere. Sure, all good. So stage working, data's flowing, database filling. Looks really nice. We're like, okay, we're on a roll here. So we're going to take 2 POPs and we're going to take it easy and see how it goes. And we start deploying it. Data's flowing, database is filling. All good, right? We're happy. Kinda, right? This never goes right the first time. We all know that. So, but there's nothing like a production-like environment or the production environment to test in. So that's where we go, right? So we ran into problems. Everybody ran into problems. Some call them challenges. I prefer problems because they can be fixed usually. So what happens? Massive amounts of data, essentially, right? Take a random router in any ISP. It's gonna have a couple of uplinks, right? We all want redundancy. We don't trust 2 anymore, so we at least need 3, perhaps 4, right? You get a bunch of IXPs, and then you get your internal peers, and then you get your customers on top of that. Considering that a ISP for IPv4 gives you close to 1 million prefixes these days. Do that times a couple of them, do that plus the internal ones, times that 2, because you got pre and post policy data you want to look at. So we're over 20 million prefixes already. That needs to go upstream per POP, per router. So 2 routers per POP is massive amounts of data. And that works fine on the producer side going upstream, but consolidating that into the consumer side is challenging. On top of that, what even was more challenging is that the original code that we used had a throughput of 30 messages per second. It was good in math. So 20 million, 30 messages per second. That's like 200 hours at least of going through that to get that. On top of that, it's no surprise to you guys, but it seems that the internet, even though BGP is a stable protocol, the internet isn't, right? There's just continuous updates on the internet, stuff is changing, updates flowing, and LRI packets are going in every time coming in. So by the time that you're done, you almost start over because it's unstable. So first thing that we fixed or improved is bump up the speed, right? So I got to take a look at the code, look at it, and see, okay, well, there's currently 1 synchronous producer in that code. What if I make a pool of them and do as many as I got virtual CPUs to my access, which we ended up on 4, and then I was able to push up to 45K messages per second. So that went from hours into minutes, and that was good, but is it enough? The thing is, if going back to the use case, what we're really interested in is customer data. That's the most important part. So do we actually want to store and to transmit all of the ISP prefixes into Kafka, into the database? Because Kafka can handle it, right? If you produce large amount of data, or you produce enough, that's all fine. You can consume it. But throwing millions and millions of records into a Postgres database, single instance, then yeah, it's going to break pretty soon. So what we did, so on the collector side, right, close to the POP, close to the routers, or sorry, not close to the POP, on the POP, close to the routers, applying filters, right? We know which are ISPs, right? We know which ones are internal, and the internal peers we don't actually need to know because we already learned that from somewhere else, right? So that part is already redundant. So if we take all of that part out, right, and we focus purely on the customers, on the customer data, customer peers, and therefore the prefixes of them, we end up in thousands of entries, right, and not millions. So throughput became much better, or not better, it's a shorter time. By having still all the data going through the collector, but not having to push it all to Kafka, we have two things in one go, actually, because we can have the access or the data of the customer, we got that, and that's going upstream. But since we're processing that through those filters that I mentioned, we can actually just create a Prometheus metric with that, or a couple of those. So we can identify, okay, this is an ISP, that's an IXP, this is a customer, this is an internal peer, and we got all this information, which end result as a side bonus, the network operations team and the engineering team and all the teams can just go to a dashboard and say, well, actually, what happened to that peer 3 days ago? And we can have that as a side effect in as BMP. We now have that part as well. So that wasn't planned, but it is a good side bonus with that. So another challenge is, I mentioned that the instability of the internet, right? So if you think of it, and we got a big audience of engineers here and people that know BGP very well, awesome. So BGP updates, when do they happen, right? And more tricky is, when don't they happen? So when you have an active peer, all good. The first time it comes up, it says, "Hey, yeah, we got a established, all good. You got NLRIs, and we got BGP updates, awesome." So that's the happy flow. If the peer goes down, you get withdrawals, all good, happy flow. What if a change is happening, right? And the remote side has this prefix list outgoing, and it would previously send 3, and now it sends 2 prefixes. If he's nice and he does a soft reset on it, then you get you get a BGP update or a withdraw saying, hey, well, now you got 2, so throw 1 away, and all is good. Not everybody does that, right? So what happens if you have your peering session, right? And the customer makes a modification, and instead of 3, he's sending now 2 prefixes, right? And he just plain boom, hard reset, BGP peer goes down, and after that, he's only sending 2 prefixes. What happens in the original code is BGP says, well, okay, well, peer went down, flushing the database, everything gone, but that wasn't implemented in the code of BBMP to Kafka that we used from Cloudflare. So on the database, that was still always marked as, yes, that prefix has announcement true. So when we looked at that, like, okay, the customer was changing that or seeing that data in real life. It's like, well, that's green. Well, the router says it's not, right? Not a good thing. So found that. Fortunately, the interfaces for that were already there, though not implemented. So pretty easy fix. Change the protobuf, change the field, change the enum, that it is peer down session. Whoop, we can, not flush the database, but at least set the announcements to false, because we still want to keep the data in the database so we can have the other teams see that over time things have changed, right? Because they still need to update it. They don't act on the absence of data, right? Back to focus. So those were 2 of the things, 2 of the challenge that we encountered that have been fixed. We're still working on big company, Thales, as Michael mentioned. So still working on getting that open sourced and getting that back to the community. Work in progress. So focusing, we got single purpose, right? We need this data to be presented towards the customer, and we got these building blocks. We're going to focus them, right? So a collector does that, right? It doesn't do more, and it receives the data from the router, parses it, puts it in a protobuf, sends it on to Kafka. Consumer then processes that, throws it into the database. The database, what it does best, store data, right? And we got the API gateway where primarily one team, right, towards the customer is consuming that data, but essentially anyone in the company or any other team can reach out to that to the gateway to get that data that they're interested in. I mentioned Prometheus, and Grafana was the bonus to that. So building this code is relatively easy, right? It's a bunch of work, but easy. Keeping things easy is really hard. So that's what we're going to focus on, and what we need to keep focus on. And this is just one of the projects, right? So we need to do that because historically we found out if you take sometimes the easy way and just adding a new feature and another one, you're going to end up in a solution that does 20 things instead of that single purpose, previously identified thing that you wanted to do. We don't know how that's going to work, right? We don't know what the future is, but we know that we're going to focus on that and try to keep our deal with ourselves, be a good friend to our future selves, and not having to worry about that in the future, hopefully.
Yes.
That's us.
That's it.
Thank you very
Thank
much
you.
for your time and attention.
Oh, questions already. Excellent.
Oh, this one is for you. I can feel it.
Yes, it is. I'm guessing from your example, you've read Exactly by Simon Winchester.
I have indeed, yes.
Right. So it's good that you use building blocks as an example because, brief history for everyone else, Ford built the ability to make all of these parts the same.
Mm-hmm.
He built that on the back of a Swede, a guy called Carl Johansson. Probably shouldn't be talking positive of Swedes whilst in Denmark. And what he did there was he defined the measurement in those days of the inch. Obviously, we're metric now, but he defined it as 25.4 millimeters. The problem with software is, we've got these building blocks, we've got these libraries. Yeah, I'm sorry, we changed that in version 3.4.8.9 dash Tuesday's build.
Yep.
How do we bring this idea of the standardized building blocks, standardized interfaces, whilst also not having the fact that everyone keeps changing it all the time?
Short answer is I don't entirely know, but we're working on it. I think it becomes down to how good is your change control, how good do you keep up with what's changing in the environment, how much time do you actually put to looking after and caring for the code that you have, as opposed to what most of us have done for the last 30 years, which is great, I've written that, and go over there, and I'll go and do the next thing now. Right, and that's kind of the thing we're trying to build into this team that I'm then moving into the rest of the sort of my purview of engineering in Imperva is. Just because you finished it doesn't mean you can ignore it. You have to go back and look at it periodically and do it. And I think that's the mindset we have to get into, because we're quite good at doing it with network groups, and we're quite good at doing it with cleaning up IP space and that kind of stuff. We're terrible at it with software, and we've always been terrible at it with software.
Google described that as landings, not takeoffs.
Okay. Thank you.
Well, at least you had versions on there. That's already something. It was just not the latest. And that could have been worse.
Any more questions? Thank you for a great talk. Please come back and tell us how you're going to fix it next year.
Yeah. It's a date.
and what the new unit of measurement is going to be.
Thank you very much.
And some small...
Yep. All right.
Great. Thank you very much.
Thank you very much.
Thanks, Fergus. Nice to see you again.